Alright, John, we're going to continue on to the next section of Chapter 16, which has to do with the binomial theorem. Now, a binomial is just a term that has, or just a, what am I trying to say? Something that has two terms in it. So like a plus b, that's a binomial, or a minus b. And what you're going to see is if we're going to expand these and multiply them out a bunch of times, we're going to see that instead of foiling 100,000 times, we actually have a pattern that we've developed in order to rewrite these. So a plus b, this whole thing to the 0 power, well, anything raised to the 0 power is just 1, so that's really easy. A plus b to the first power, that means that we're just taking that binomial and multiplying it one time, so that's just a plus b. Those two parts are really, really easy, but this is where we get into the more complicated stuff right here. Actually, we don't really need those parentheses around it. It's just like this. Once you're taking a binomial and squaring it, that's when we learned about the whole foiling method, and that was probably like around 8th grade, 7th grade. A plus b multiplied out 2 times, and then let's see what happens. That's going to be a squared plus a times b plus another a times b. That's going to give me 2ab, and then that last time is going to give me b squared. Alright, so that's the term that we get when we multiply out a plus b 2 times. Let's see what would happen if we did it out 3 times. Now, if this is what we get when we do it 2 times, we're actually doing a plus b times what we just did, which is a plus b squared. So instead of foiling it out 3 times, we can actually take that previous term and go like this, and then we're going to have to multiply, double distribute, all sorts of fun different things. How would I do this? Well, if you're used to working with a Punnett square, maybe you could make a 2 by 3 box and you could do it like that. Or you could do a times a squared gives me a cubed. A times 2ab gives me 2a squared b. A times b squared is ab squared. Then I have to multiply through the b's. This is a squared b plus 2ab squared plus b to the 3rd power. And then we could go through, we could simplify all those and combine some like terms. Like we have 2ab squared right here, and we have another ab squared right there. We have a squared b, and we have 2a squared b right there. So this turns into a cubed plus 3a squared b plus 3ab squared plus b to the 3rd power. And this is just really time consuming. It takes a lot of work. That was just ab raised to the 3rd power. If we have to do it to the 4th power, it's just going to take even longer, and it's going to get more and more complicated every single time we do it. So, just like good mathematicians, what we've done is we've kind of recognized patterns that we could use. So instead of having to FOIL out every single one of these, we've learned a pattern that we could use instead. And I'm going to explain to you, I'm not going to explain to you the pattern quite yet. Well, let's see. The first one, we got just a 1. Then we have 1a and 1b. Then we have 1a squared, 2ab, and 1b squared. Then we have 1a cubed, 3a squared b squared, 3ab squared, plus 1b cubed. So what we're beginning to see is a pattern that we notice with the coefficients that are in front of those terms. And that pattern is what we call Pascal's triangle. Now, I don't know if you've ever seen Pascal's triangle before, but Pascal's triangle starts with a 1. And then the 1s continue down along the edges each side. But what you kind of start to notice is that you do the 1s repeat there, and then 1 plus 1. These two 1s added together, that gives you a 2. And then you see the 1s there and the 1s there. Then you see the 1s, and then the next column is 1 plus 2 gives me a 3. 3 plus 2, or I'm sorry, 2 plus 1 gives me another 3. You see the 1s continue down on the outside. In the next row, you see 1 plus 3 gives you 4. 3 plus 3 gives you 6. 3 plus 1 gives you 4. So I don't know if you've ever seen this before, but it's actually a really cool pattern. And this guy, Blaise Pascal, came up with it a long time ago. And this guy was really into probability and gambling and all this sorts of crazy stuff. So you can see that the pattern continues. And it wants us to go ahead and fill in the next 2 rows. Okay. So I'm going to continue out. There's going to be a 1 there. And there's going to be a 1 on the outside here. So to fill in this number here, all I'm going to do is take the 1 and add it to a 5. 1 plus 5 gives me 6. The next number right here, 5 plus 10, that's a 15. The next number, 10 plus 10, gives me a 20. 10 plus 5 on the other side. You can see how it's a mirror image as you go. Right down the center. It's always like a mirror image. It's symmetrical on both sides. 5 plus 1 gives me a 6. So that would be the next row. And then if we continued on and we went one step further, you still have the 1s that are going on the outsides. And then you have 1 plus 6 gives you 7. 6 plus 15 gives you 21. 15 plus 20 gives you 35. 20 plus 15 gives you 35. 15 plus 6 gives you 21. And 6 plus 1 gives you 7. So you can see how that pattern kind of continues every single time.